Okay. Hello, everyone. Welcome to today's webinar. I'm Erin, our resident webinar host here at Softree. And with me today, Matthew Dickey, our, I should say, resident webinar English lead. So today's plan, we are going to do a little bit of a tour of terrain tools with an emphasis here on the word tools. We're going to be focusing on a few different groups of tools within the module/program that allow you to create site designs, do terrain modeling, import, export, all that kind of fun stuff. So before I officially get into it, a little bit of housekeeping. First and foremost, everyone here in the live webinar, you're going to stay muted throughout the presentation, but that does not mean that we don't want to hear from you. So if you have a question, please open that Q&A section of your GoToWebinar panel, type in your question, and we will tackle it at the end. And for those of you watching this in the future off of YouTube, please ask us questions in the chat. We are happy to answer them. Okay, so the terrain module. It is a standalone program known as Terrain Tools. It also is the terrain module that's included within RoadEng. So pretty much every single product that Softree makes, terrain is included. And today we're going to really focus on some of the different groups of tools that are inside of that module that can allow you to achieve some of your projects. So we're going to put these into sort of 4 buckets. The first one of those, survey data and control tools. So here we'll talk a little bit about importing conventional data, LiDAR, thinning, all that kind of fun stuff. And again, that topic we cover pretty extensively in almost every webinar. So we are going to be not too in-depth on that section. The next group of tools, we've just called them spatial tools. So these are ones that can help you generate additional context or data within your project. Something like live maps, which is background imagery, the new polygonization tool that we launched in 12, and the streams and ponds tool that's part of our larger hydrology toolkit. The third group beyond that is kind of probably gonna say the biggest, meatiest, most fun part of today's webinar, and that's all about earthwork tools. So we're going to be taking a look at grading auto balance, and a buffer benching tool that can allow you to achieve some of your site design goals. And then lastly, we'll call them output tools, but really they're just output options, and that's where we'll end. So as a reminder, when you open terrain, blank white screen, so that essential first step is data, survey data, specifically going in to be able to generate your terrain model. And so we will start with the first group of tools, which is the survey data and control tools. So on the conventional data side, we're going to talk a little bit about tools that can allow you to control break lines, the line work symbology, as well as tools that can allow you to remove bad points or even possibly change the labeling of a point or a point type. And then from there, we'll talk about point cloud data. So here it's all more about controlling how much data you have, because point cloud data, whether it be DEM or LiDAR, they tend to be really large files. They're dense, often more data than you need. And of course, the more data you put into a project, the slower that project potentially could operate. And it's not uncommon, especially in the resource and renewable space, for us to see people dumping in monstrous files of hundreds of millions of points. And with that, really important to lean into some of the tools that we have that allow you to control that volume of data, whether that be tools to create an area of interest, tools that allow you to do thinning. And so we're going to start there. So 4 pieces in the webinar. This is the first of 4. I'm going to pass it over to Matt. We're going to go into the software, talk a little bit about the survey data and some of the tools you have to control it.
All right, perfect. So, as Erin said, pretty much every project starts similarly, where we will open up a blank instance of terrain and bring in our topo data or survey data. So I'm going to just pop open terrain. And we're going to click Insert File. And I'm going to grab my survey data. So I will break this into kind of 2 different examples for the 2 different types. But if we're dealing with conventional survey data, so say maybe something's surveyed with a total station or an RTK, we can bring that in. Now, what am I talking about with that? Well, I've got a CSV. So it could be a CSV, could be a text file. etc. But it's pretty common to have something with point numbers, coordinates, and a point code. So we're going to bring that in. We'll hit open, and right off the bat, well, I've got a bunch of different options set up depending on what I'm working with, but one of the defaults that everyone will have is this ASCII text. So I could click OK here. I could bring it in just using those default settings, and I'd get something that looks similar to this, where all of those points are kind of treated the same. Now those points to start are 3D points. We can turn them into a surface still by clicking Terrain Modeling, Generate, and I'll skip the contours here. But we could see, well, we can generate a surface from that, but obviously it's not the tidiest surface here. So if we were really up against it and we wanted to go through and play connect the dots manually here, we could. I'd select those points, I'd hit join, then maybe I make that a break line so the triangle edges don't cross it, and we click generate, and there we are. So we could go through and we could manually do this, but I'm going to delete all of this. So there is a better way. So going back to where we were, we can click insert, we can grab that same CSV, and here we can bring in an IOP that's already been set up. So and there's other webinars where we cover just setting this stuff up and really diving into while working with conventional survey data, but a real high level overview is we can say what column's what. So my X is the third column, my Y is the second column, and the code's the fifth column. And that code is important because we can take what those points are collected as. So center line, for example, be brought in as a polyline. Top of bank, brought in as a polyline. Now it's being connected based off that code. It's being treated as a break line. It's going to be a teal line with that line type and that symbol. And we can hit OK. And now instead of just having those 3D points, we've got 3D points and lines, and those lines are formatted the way that we like. So again, break lines are break lines. Other lines like this fence line is not even included in the model. So when I take this and I remodel this stuff, we can come in here and we see those break lines make those nice crisp edges, but things that, well, aren't tagged as being in the model are, actually let's just tile these side by side. So like this guy here, it's not included in the model because the model property isn't set. So these model properties control how the software is visualized and interacts with the model. And then of course we could also do things like change our line work if we wanted to change our line work. Or maybe we add in labels on a selected feature. And sure, maybe we want to see like, let's do elevations. So pretty easy to manipulate that stuff, control how you see it, control how it controls the surface, etc. Now, again, just kind of broad tour level overview. We're going to jump out of this and we're going to look at something quite a bit different from this conventional survey data, which is relatively sparse, and we use the geometry of the lines to control the surface. And let's switch gears over to some LiDAR data. I'm going to just close this out. I won't save it. Opening up another instance. We're going to click Insert File here, and I've got my DEM. So here, whether we're working with DEM, LAS, etc., it's all kind of the same when we're in that remote sense data type. So here it's a TIFF. The TIFF could be an image, or it could be, well, raster data set. We're selecting that we're treating it as a raster. And we could thin it on import, but I'm going to skip that. We're going to do our thinning after the fact here. So we've brought that in. We've got this big magenta blob showing up. If we look at the 3D view, we can see still just 3D points like we had before, but of course they're much tighter spaced. We can click off to the side so those selected features, the display properties turned off, and we can click terrain modeling, generate, and we can generate, well, a surface and contours. Now this file that we're looking at, it's quite light and easy to work with. So we've got, say, 1.3 million points in this file. If it was much larger, say like 50 million, 100 million points, well then we don't have that challenge of really defining where edges are with break lines. We have kind of a data management problem on our hands. So if we wanted to reduce the amount of data that we had in here, well, if it's DEM data is nice where it's all on a regular grid. We could use the simplify tool. So we can come in here and we can say, well, I'm going to set a tolerance. I'm going to use a tolerance of 15 centimeters. Actually, I'm going to get rid of my contours here just because I don't want them to clutter up what I'm looking at. So with that, and I'll tile these again side by side, we can see on these planar areas, I've got much sparser data, but on these irregular areas, I'm still getting a fairly dense data set. So with this dense data set, I can remodel that tin, and we can see, well, we're still doing a pretty good job of preserving the shape of our surface, but instead of having that 1.3 million points, we're down below 300,000. So that's one tool in the toolbox when it comes to thinning. And then the next thing that we're going to do here is we're going to assume that, well, maybe we don't need all this area as high resolution. So for that, I could just, well, draw in a boundary feature, and I could do the whole thing just drawing my edges in. Of course, it's sometimes nice to have nice regular features at the click of a button. So I'm going to just take that diagonal I have drawn and turn it into a rectangle. So this feature is tagged as, well, that's the feature. I'm going to call it AOI, just so I can keep track of it. And I'm going to come up to the terrain modeling tab. I'm going to click simplify. And here I'm going to say, well, I'm going to make it so that there's no more than, say, one modeled point per regular rectangular grid. I'm going to use a 30-meter grid size. But inside that box, I'm going to exclude it from that simplification. So we'll hit OK. Now it tells us we're going from that 241,000 modeled points to under 100,000 here. We'll hit Control A just to see the difference. So we see pretty tight spacing. We've got those little points off to the side. And again, I'll get rid of my contours just so it's easier to see. So quite sparse. We can remodel that tin and see, well, what we're dealing with. Well, high resolution inside that AOI, and then much lower resolution outside of it. Again, if we're worried about working with really large files, yeah, it's quite easy to manage that. So with that, I will pass it back to Aaron. Now, I am not going to save this. Of course, it's a fairly concise file. I'll dump the data in again and just work with it in its full resolution for the entire area for the rest of our example. But yeah, pass it back to Aaron.
Okay, so that was kind of group of tools number one. We talked a little bit about how to import, and then we covered a few different tools for allowing you to control that survey data. I do want to just kind of re-emphasize, Matt used an example there that from the get-go was well within our quantity of points that we would recommend using. So, kind of keeping your project, I think our recommendation is like 15 million, I don't know, somewhere around that. So above that number, that's where those tools really, come into play. Yes. Moving on to our next box of tools. This is kind of that additional spatial tools. These are ways to add more context and more information to your project. So the first of which is part of our hydrology toolkit. If you'd like to learn more about the rest of the hydrology toolkit as well, some great webinars up on our YouTube channel. And this is streams and ponds. So it allows us to generate the likely location of streams and ponds on your landscape. Very useful, of course, when you're planning roads, planning sites, understanding where the water is quite important. The second tool we're going to cover within this little box is called Live Maps. And as long as your spatial data is georeferenced, you're able to bring in background imagery that's going to come from MapTiler, from Google, or from Bing. And this can just add additional context to your project. Of course, if you're working with a high resolution ortho photo in the first place, skip this tool. But if you're not, again, great additional context as you go to do your work. And then the third tool we're going to cover in this section is called our Polygonize tool. And this is a new tool that's coming out in version 12, currently out in beta testing. It allows you to delineate your terrain based on think properties like slope or aspect into different polygons. And a lot of different applications and uses here. For this, of course, it came out with our digital pre-planting tool that can allow you to figure out how to, plant and organize digital planting in forestry. But again, lots of uses, even if it's just locating steeper slopes, the Polygonize tool. So that's it for me on this one. We're going to go back to Matt, and we are going to look at the second batch of tools, spatial tools.
All right. So, and yeah, just to reiterate, my file here is quite easy to work with. So I'm going to just open up terrain. We'll bring in that, in this case, that DEM data that we just had. And I'm going to linger on one more thing here, just to, well, same file. This projection tab will be important if we want to be able to connect to things like Google Earth or other web map tile services, or if we're mixing data that has different projections in use. So that DEM is going to carry the projection with it. Great, we'll hit OK. We'll model that surface. And, well, what if we want to add a little extra context to what we're dealing with? So first, of course, an image is nice to understand what it is at our site. I'm going to just select the bounding box around my data. I'll come up to home. I'll click import. And, well, we've got that Live Maps tool flashed up. So with this, we have a few different map sources by default. Now, in this particular example, the LiDAR actually matches the Bing data more. So the Google Earth imagery, well, between when the LiDAR was flown and when the Google Earth imagery was captured, there was a road built. So in this case, it's going to be nice to have the more recent data for that extra context. So I'm going to download that. If we had our additional sources that we wanted to connect to, we could using our own provider here. I'm just highlighting the area that I'd like to isolate for download. I'll hit save and we'll download it. And of course, this is another thing that's kind of nice, where if you're connecting to these web map services, we are downloading the data locally, and that gives us kind of that benefit of having a record of why we made the decisions we made when we were in that design phase. So if we go, say, 5 years from now and open the project back up, well, why did they do that? Well, we can see the same things rather than connecting live to the service. So this image, I'm going to just save that in here. And I should mention too, I'm connecting to Live Maps. If you have your own imagery, you can very easily bring that in as well. It doesn't have to become from a web source. So we've got our imagery in there. So that's one of the 3 items ticked off our list for this one. I'm going to just flash open that 3D view. And to make it a little easier to see what's going on, I'm going to hide that image. So I'm going to hide it in the background. So aside from just seeing the imagery where the trees are, etc., it's oftentimes nice to know where the water is. So for that, we have our hydrology tools. And of course, there's more than just streams and ponds. So if we wanted to calculate the drainage area to a point, or watersheds, or calculate where water flows from a point, we can. But here, and probably the most common one to use, is the streams and ponds tool. So we'll click this guy here. we've got our inputs. Big thing is that it's looking at how much water flows, or how much drainage area flows to a given point before the stream is generated. And we can see, well, we've got those streams, and then we've got the ponds as well. So pretty slick, pretty easy to work with. And then the next thing, well, maybe we want to delineate where we have some higher elevation stuff that we'd like to avoid. Maybe there's a project where that's beneficial, maybe low elevation stuff for maybe flooding, maybe aspect. But again, another common use for this next tool is going to be, well, where are my steeper areas? So for this, I'm going to click the feature tools. I'm going to click polygonize. And we could run this tool on just a specific area if we'd like, or have it exclude it from specific features, but I'm going to use the total extents. And while I'm not interested in my elevation or aspect, I'm interested in my slope. Now for this, I could create a Keller ramp. And we have that transition kind of going up the way we want, but that's not really what I'm going to do here. It's instead, I'm going to isolate it by categories. So for this particular project, I'm going to say, well, I'm interested where the slope is steeper than, say, 40%. Beyond that, it gets hard to operate equipment on it. So we'll go from 40 up to a slope of 55%. And then from 55 to 75, well, 55 onward, it gets hard to store material or fill. So I'm going to make another category of that. We'll go 55 to, let's say, 75. And we'll make that orange. And then from 75 onward, well, we're going to say that's really steep, really ugly. I know I want to avoid that altogether. And we can do that here. I'm going to make that red as in don't go there. Next, well, I don't want to make any features that are smaller than 50 square meters, and I don't want to, well, the cell size that I want to use here is going to be 5. So we'll hit OK. We can see what we're dealing with here. Now my 3D, we can see the outlines of those features. If we would rather, I'll have those filled in, we can drape our plan view on that 3D as well. And that goes for the ortho too, but there we are. So we can see where those different categories of slopes are as we're working and make more informed decisions, or just look at it in the plan view and see where the steeper terrain is at a glance. And then lastly, well, if we want to turn that drape off, we can just come in here. And with all of this stuff, if we want to eliminate these system generated features, well, we can just go up here rather than selecting them with any of the variety of selection tools we have. I'm going to get rid of my slope range polygons, and I'll pass it back to Erin.
Our next bucket of tools we're going to talk about, as I mentioned in the introduction, this is probably our largest, most robust section. And this is really the tools that help you do earthworks projects. Specifically, one of the most common ones being grading. And this is really where we can get the software to project a feature at a specified cut and fill slope angle onto a target surface, typically the original ground. Lets us generate slope lines, daylighting, and then you can calculate the volumes for that new surface, essentially. So grading, one of our most typical earthwork tools that we use, great for pads, ponds, all those kinds of pits as well. From there, we also have the, I'm going to say, smarter, more interesting version of grading, which is called auto grading. So this one, a little bit more intelligent. What it's going to do, it's going to automatically adjust the elevation of that graded feature in order to hit a very specific volume. So you can ask it to have a surplus, you can ask it to balance, and the software is going to figure out what the elevation of that feature, or that end surface, I should say, should be. So really intelligent way, especially if you're doing site leveling, a graded pad. This is a fantastic feature to use, going to take a lot of the guesswork out of it. And then the last of our earthwork tools, this is a new one. It's coming in 12 as well, out in beta testing. We're calling it the benching buffer tool, or buffer benching. Name exact name TBC, but what it allows you to do is create a series of features pretty much in a single click. So it's pretty ideal if you're doing pits for mining, or something where you're going to want some steps to that feature. Buffer benching, pretty rad tool. We'll get into that. One concept, just to mention, put a little emphasis on. I mentioned, especially with grading, we're going to be, targeting a surface. That target surface typically is the original ground. And the big trick in our software is that we create that original ground surface, like the file Matt's been working with. We would save that, and then we would do all of our grading and work with that file in the background, so that when we are targeting it, we're not modifying that original ground surface. It's in the background, and we're working in reference to it. So, software toolbox number 3, earthwork tools. We're going to head back to you, Matt.
All right, so picking up from where we left off, I've just saved this file. So it's called topo.trx. And yeah, as Aaron said, important concept. We want to use this topo surface, but our design is going to be in another train file, and that's going to be the other surface. Now, so at our very least, if we're doing a design project, we'll have 2 train files, but we can have more. So that ortho imagery, we might add that, and other background information that we'd like to see, we can add as many as we'd like. So I'm going to just minimize this. We're going to flash open a new instance of train. And I'm going to right click, plan options. We'll click this guy here. We'll click add. So I'm adding in that topo as a background. So I want to be able to target where my cuts and fills are measured relative to, and where those slope lines extend to relative to that. But we can add in more surfaces, or sorry, more train files if we'd like, or surfaces too. But here I'm going to just grab that image and we'll include that as well. We'll click zoom to extents, and there we are. So we can see those other train files from this current train file. Now for this, if we were designing anything, maybe a pad, a pond, etc., well, we're going to want to define geometry. And of course, we could insert that if we had, say, a pad footprint given to us, but a lot of the time we won't. So we're going to just create new features to represent our design features. So we come up here, I'll call this pad, and maybe we want to draw something in, and we could do that kind of, well, freehand. We could go as irregular as we'd like with it. We'll go close. Now with this, if we wanted to smooth it out, well, we could come up here, we'll use the smooth option. So we've got those edges. And then we could take this guy and we could, well, hover. We could see that our tin's at an elevation of 188, 189-ish on the high side, 184 there. We could shift this thing. Well, maybe we want to have it at an elevation of 178. So we could take this little hole that we've created, and then we could go over to this guy here. We could grade to that topo surface. We could tell it to interpolate additional slope lines every so often. And voila. So I've got a lot of cut, very little fill. That makes sense. We can click on the 3D view, see what we're actually dealing with here. And well, let's change how this looks a little bit. So current, I'm going to make it that color. This guy here, I'm going to make it a little easier to see through, but I want it to appear as a surface, not just a opaque or totally see-through. So there we are. So that's a really simple example, maybe a pond or a pit without benching. Now I'm going to delete this. We're going to tile these side by side. So we may have a need for something that's entirely free-handed. But a lot of the time, particularly if we're dealing with like building pads or something like that, we're going to probably be best off with a little bit more of a hybrid approach. So we'll design a quick pad here. So we're going to set our pad with a center line and a bit of a crown on it for a crossfall. I'm going to call this pad CL. Now I'm going to start by defining this feature with the mouse. We can come over here, so kind of the same area. We'll run it from there to there. Now with this, if I wanted to have that on a certain slope or a certain length, instead of doing it with my mouse, I might draw that feature in and or use tabular inputs. So, and here, of course, I probably don't want to define it by the exact coordinates at either end. So I'd go survey format. Well, I want this to only be 60 meters long, and I want to have it go down on a slope of 0.5%, and voila. And then if we want to shift that up to a specific elevation, we could. So I'm going to go 189. And then that feature that we have, so that's our center line, we want to crown off of it. Right click, modify, buffer. Now I'm going to go off both sides of this, so left and right. I'm going to keep it rectangular. I'm going to say we're going to go 30 meters either side. And I want that crossfall to be 2%. So I've got those lines. Now I'm going to take this over here. I'm going to take this over there. I'm going to join those two features, and then I'm going to close those two features. And voila. Now here, I want this to be a break line, and just so it's a little easier to see, I should have done this earlier. I'll make those a little heavier lines for folks. So there we are. And we can do that same grading exercise coming off of that feature. So again, same concept, target that topo surface, set our cuts and fill slopes at whatever we like. I'm going to tell this to set that spacing at 5. We'll calculate our volumes at the same time. And there we are. So we've got that. Now we've got a little bit of cut. And well, if it's a building pad, maybe we're better off if I'll move this over a little bit, but also move it up and down until we get it to balance so we can minimize how much work is required. So I was going to just use the quick keys, but I'll try not to do that so it's easier for folks to follow. So if I want to move this, I'm just going to grab it by vector. We're going to grab this over here. Sorry, I grab it by box rather than vector. So I'll scoot it over a little bit. Once I'm happy with that horizontal position, I'm going to take that and that. And instead of using the grading tool, I'm going to click the optimization button, and I'm going to use the auto balance tool. So here, if I want to finish up with a net surplus of 0, great. We'll leave it as is. We'll hit OK. We'll let this think. It's going to shift it up and down until we get to that sweet spot where our cuts and fills are equal. So pretty slick, easy to design things like pads where you want them to balance. And yeah, I will save this just because we will come back to it. And let's do that benched pit next. So, and I'll use the same example. There are same files for my example. We'll just build a pit in that one instead of a pad. So a little bit of repetition, same concept. We've got a new instance of terrain. We're going to dump in whatever we'd like for our background. So I'm going to use that topo as my background. I won't worry about the image here. We'll click zoom to extents. Now I'm going to do that same kind of concept. I'm going to make a rectangle. So this is going to be my pit floor in this case. We're going to move it around a little bit here. Now, it's a pit, and I want it to be deep enough so it's interesting. So I'm going to just hover here. Okay, we're elevation of 182. Let's assume we want to go down to, say, 175. So I'm going to shift this down to 175. And the big thing that's going to be different with this is, well, we're going to do the same concept of grading, but we're going to use the buffer tool for that. So we're in here. Now I'm going to say I want to have my benches, let's make them 5 meters high. So let's go with that there. So horizontal offset of 2, and I'm going to use slope of 400%. Now I want to do this over and over again in order to get out to a reasonable height. So I'm going to add that benching in there. Now my benches, I want to have those benches set at, say, a 4 meter bench width. We'll set that. They're a little bit sloped back to manage water, rockfall, etc. And we'll tell this to kind of repeat itself up 8 times. We'll hit OK. And well, we've got something that looks like that. Now, what does this look like here? And again, I'll just make it so we can see both of those surfaces. Well, I'll make a surface first. Oops. And they should be break lines for this. So we're going to make our design surface. So it goes way up, probably beyond what we intended to. We've got this other surface. So we don't want to have kind of filling into the sky. So, well, how do we trim this, kind of lop it back to where it should be? Well, we can click calculate volumes, and we can turn on this guy here. So we're going to calculate where these two intersect with each other. So this line is what I'm interested in. I'm going to take that line. I'm going to break everything that it crosses. Now I'm going to select everything outside of that line. I'm going to hit delete. Now this line, I'm going to use that to kind of define my surface edge. We'll remodel it. And let's make it so we can see all through that other surface. And there we are. So we've got our benching where the benching is required, and away we go. So that's the benching tool in the buffer. So with that, we've got some design functionality that we've covered. I'll pass it back to Erin.
The last group of tools we're going to talk about today in the webinar are the tools that help you do some output. And the first one of those is one we actually don't talk about too much in our webinars, which is the ability to export directly into Google Earth. A big benefit here of exporting into Google Earth, it allows you to really quickly validate that your coordinate system is right. So you can select features, export them out to Google Earth. The next output tool we're going to talk about is multiplot, and a big asterisk here. Location, so if you are a RoadEng user, our location module multiplot and terrain module multiplot are actually quite different. Terrain is a single page, allows you to still import those views, create, a different looking output sheet, but it is a singular page. And then lastly, the stuff we're not covering, we export and output to a wide variety of formats. That could be DWG, DXF, some gridded formats. You might want to take your project out to a Venza. So lots of other options in our export output section. And with that, Matt, You've got 4 minutes. Passing it back to you.
Back to the pad. So with this, if we want to share this with a colleague, we could come up here, we could hit File, Save As, and we could change our format to whatever we'd like, including KMZ, so we could do that here. Now, we could also go home, and there's an export button, so we can write it right to KMZL. See, now this warning that it's giving me, so coordinate system is undefined. So my topo, I defined the coordinate system, but I didn't do it when I set up this. So until we've defined our coordinate system, it doesn't really know where all these numbers represent in the world. So for that, and we could follow the prompt, or we could come up here, and before we got to this point, we could have said, well, I want to use whatever coordinate system I want. And in this case, it's a somewhat obscure coordinate system, so I'm going to define it with a PRJ file. So now when we come in here, we can click export. Oops, and of course we want to click the right button. And it's going to open up Google Earth for me, and we'll see where we land here momentarily. And there we are. We're right where we should be. So our coordinate system's right. We can share that file. Great. Now the next big item here is, well, aside from just sharing a digital copy, and again, if we wanted to share something like an XML for construction, we could just save as. But to put together our documentation, well, we can do that kind of manually. So we could come over here. So this is our multi-plot editor. And we could say, well, as we set this up, well, first things first, we probably want to set our screen size to be, or our sheet size to be what we want. And then we could say, well, in multi-plot, I want to add in this plan view. So we've got that. I maybe add in rectangles, so I can add text, legends, etc. But it's not something that you have to redo over and over again. So instead of redoing that over and over again, you could format your sheets once, and you could save it with a screen layout. And as Aaron said, this does differ from how location works versus terrain works. Now here I've got one that's already set up. So we'll come over here, and well, I've got a couple different screen layouts. I'll start with this guy. Sure. So I've got that plan over profile. I've got my legend already set up. Great. Or we could do something a little different. So of course it's a 3D drawing. We might as well take advantage of that 3D aspect for our outputs. So here I've got something, well, a bit different. So we've got that plan still. Now my 3D, I'm going to want to find where I'm actually supposed to be on this thing. And here, let's just make that a little bigger so we can navigate around there a little better. So there we are. We can position it as we'd like. And well, if we want to add in a section, cut a section for what we're dealing with, we can do that too. So I'm going to just draw that in. Now, again, I'm a sucker for the quick keys. I'll try not to do it, but I almost did. So I'm going to make a draped feature. I'm going to call this feature raw section. I'm going to just define it with our mouse. I'm going to go across that feature, just like that. Now that feature, I'm going to make it a little easier to see. Also set it in the profile. And we'll make sure that is represented there, and we'll hit zoom to extents. So there we are. We can see what it is we're dealing with. We can position that as we'd like. So pretty easy to throw together our documentation. We could do the same thing for another section if we wanted to cut another section the other way with it. But yeah, pretty slick. I'm a minute over. I thought I was going to do it, but yeah.
Hey, not too bad. 1 minute over. I'm impressed. So we're at the fun part of the webinar. We're going to ask some questions. If you have one, type it in the chat. All question askers do remain anonymous. And Matt, it looks like you actually answered one of these questions right off the bat there. But just to reconfirm it, it says, for the new terrain that you used for grading, are you setting the projection there as well?
Yeah, so usually, and just to back up with that, if I was doing a new design, rather than doing it after the fact, after I'm prompted without warning, my sequence would be, well, add in my background files, whatever ones we're going to use there. Click zoom to extents, and then usually I'd come right up to the top and just set my projection at as whatever we'd like there. And this one is a little unusual, just where it's not UTM or something that I know the EPSG code off the top of my head, but I can assign that projection with the PRJ file. So for me, and we're gonna get to cover things all over the world, that's the way I do it. If you were, say, a consultant or someone working in a specific locality, you could just set that as your default. If that's always the projection that you want to use, and set it as your default, and then you don't have to worry about it in the future. So yes, we will typically set that projection if we want to use things like export to Google Earth or connect to live maps, but yeah, it's not required either.
Excellent. Okay, next question. Is it possible to put a ditch around the pad?
Yeah. So for ditching around the pad, and I won't redo it here just because I am already over my time, but we've got a couple common ways we could do that. For this one, where the pad's on grade, both directions, the easiest thing to do would just be to buffer this again. So buffer it down at whatever slope that we'd like, and then do another buffer to do the ditch floor, and then just grade up from that kind of outer extents instead. So that's one way to do it. If it was another case where maybe we wanted to have the ditch run on an independent grade separate from whatever slope that the pad's set on, we could do that too. We just define that tabularly and kind of pick our highest point, well, typically our highest point, and we'd run that around the outside of the pad. As you get into, well, just maybe pure ditching projects, of course you could do it in terrain, but location is better set up to kind of really efficiently run through those linear infrastructure projects. And yeah, big ditching projects, no different than a canal, no different than really an inverted road, and then location is going to be more efficient to tackle it. So hopefully that answers the question. And
awesome. Okay, let's do two more. The first of them, is it possible to calculate or get volumes between surfaces? So I'm assuming they're talking about a couple different terrain models.
Yeah, so that one was one that I kind of stripped out because I thought, oh my God, I'm going to go way over my time. But we can. So I'm going to just flash open a new file here. I am going to use a different file because it's a better example for this. And just to reiterate before I go in a different direction than the bulk of the webinar itself, of course, I was calculating volumes between the design surface and the topo as we designed. So this will be different, kind of more of an as-built perspective. So here I'm going to just bring in this LAZ file. Now this was LiDAR data that was flown in 2007. And yeah, last time with the LiDAR data it was DEM. This time it'll be LAZ. So pretty similar for the clicks that you follow. We'll click Terrain Modeling, we'll click Generate. And there we are. So this has a fairly large active pit in it. And I don't know if it's the, it's not the exact question that was asked, but I'm going to use that question as a little bit of an excuse to talk about something similar. So one common example for this would be, well, I want to calculate the volume, not between two surfaces, but just like a stockpile volume. So the volume contained within a single surface. So here I'm going to just draw a feature around one of these piles. I'm going to tag it in as a surface volume boundary. And we'll choose this guy here and arbitrarily. And I could have been I could have made life easier for myself there. It's a pretty flat floor. I could have just grabbed a contour. But the big thing is we want to have the surface volume spec. And we could click Calculate Volumes. And instead of doing volumes between two surfaces, we can do volumes enclosed by a single surface. And there is a little bit of a catch here. We don't want to just hit OK. So if we hit OK, it's going to calculate basically all the volume within our total LiDAR file. And that's going to take a little while to calculate and not give us anything useful for this case. So we're going to turn this on, and it's going to report the volume within that polygon. And there we can see, well, we've got a volume. If we were to excavate that out, we'd have a volume of 2,743 cubes. And what's relative to what is kind of arbitrary here. We can switch whether that's counted as cut or fill. So that's one aspect of kind of more that as-built volume calcs. Now comparing two different surfaces, I'm going to just save this as 2007 so I don't get confused. But we can do kind of, well, similar between two different surfaces. So in this particular spot, I happen to have 2007 LiDAR data, and I have, I think, 2019 LiDAR data. So if I'm interested in how much was excavated between those two surfaces in that amount of time, well, kind of like our design versus topo, we're going to have a different terrain file for each. So I'm going to bring that LiDAR data in here. I'm going to click Generate. And I'm going to, I'll save it, just again, more for my own benefit, so I can look in the top and see what year's what if I happen to forget. And, well, if I want to compare a specific area of these two, well, we can. And just to avoid me kind of drawing in a polygon in a spot that doesn't make sense, let's add in the background for that other. And here, to make it easy to tell what's what, I'm using gray contours for both. I can cheat a little bit, and I can make that other surface, all the line work in it, be a color other than what it's supposed to be. So there, I can see that there's a pretty big deviation along there between the two surfaces. So let's call this, well, again, AOI. I'm going to tag it as a surface volume boundary, and I'm going to say, well, I'm interested in what's different. I'll just do kind of this main excavation. It keeps going back further, but what if I close? what got excavated between 2007 and this little box that I've drawn in. Calculate volumes between those two surfaces, so between 2019 and 2007. Again, I'm just interested in that little area, so I've got that polygon defined. That polygon is called AOI, and it's tagged as a surface volume boundary. And we'll let this thing go. And there we are. So we've got a bit of cut. Whoops, that's the original. So a lot of cut, a little bit of fill, and we can look at how those both look in the 3D if we do want to have that actual kind of verification on how the two compare to one another. So, well, there we are. And there is a little bit of cut, or a little bit of fill. So that ramp was added in specific spots, but basically everything that's showing up as olive is that excavation. And if we want to see through it, once again, we'll just roll this back with an alpha channel that's less than 255. So pretty straightforward to compare volumes between two surfaces. Of course, the focus is on terrain in this case. If we were doing more of like a road as-built, we'd leverage location for that, so we can get the mass all automatically calculated. Yeah, hopefully that answers that question.
Awesome. Okay, guys. That was a bit of a springboard, Matt. I think we're going to probably wrap it up there. So thank you, everyone, for joining us today as we did a little bit of a tour of the tools side part of Terrain Tools. We hope you enjoyed the content. As always, if you ever have an idea for content you'd love to see us present, please send it to us. You can type it in the chat. You can drop it in a note on YouTube, or you can send an email to our support team, which is support.team@softry.com. And we look forward to seeing everyone again at another upcoming webinar. Thank you, Matt. Thank you, webinar audience. Have a fantastic rest of your day, everybody.
Thanks, everyone.